Good afternoon, all. My name is Larry, your lecturer for Engineering Science N4. I quickly want to show you one of the areas you can concentrate on for your final exams. Module 4, the topic is statics. And of course, in statics, we have just two major topics there, the beams and of course centroid. Okay, the beams can give you more marks, and in all questions that will be asked in your final exam, I strongly believe beams can give you more marks than any other topics in the book. Okay, let's quickly look at this. This is your sketch about a beam. I'll look at possible 4 questions they can ask from this beam. Question 1 is asking about calculation for your two supports here, B and of course H, which will give you 6 marks. To prove your answer, 1 mark. To calculate the bending moment about point B, C, D, E, F, and G can also fetch you 6 marks. And for you to draw shear force and your bending moment diagram, and also show the maximum point, whether at the bending moment or the shear force. If we make it like 2, and then that will give you 7 marks, we have 20 marks in total. So you can imagine only just from one topic you scored 20 marks. So let's quickly go on and start with number 1. Number 1, they are asking us to calculate for the two supports. We have B and we have H. So we say we want to take moment about support B. And we say the sum of anti-clockwise moment will be equals to the sum of clockwise moment. So let's check. Our 16 Newton, we go anti, 80 will be clockwise. Before we go ahead, we have a UDL of 4 kilograms. The first thing I will advise you to do here, turn this to a point load. We will say 4 multiplied by 9.8, that will give us 39.2. And we have over 6 meters. All right. So this will be 39.2 Newton. We have to convert the mass to weight. Okay, then our 39.2 will also be clockwise. Our 100 Newton will also be clockwise. Our 75 will also be clockwise. And our H, support H, will be anti-clockwise. So we have 2 anti-clockwise moments. Therefore, we say 60 multiplied by 2B, we have 2. All right. Plus, we have H multiplied by, from H to B, we shall have 2 plus 4, 6, plus 6, 12. 12 plus 4 will be 16. And then for the clockwise moment, 1, 2, 3, 4. And of course, this one also. This is per meter, this is per meter. So we are going to say 10 multiplied by 2. This will become 20 Newton here. and we say 39.2 multiplied by 6 will give us 235.2 Newton. Okay, and then we go ahead for the clockwise. We have 80 multiplied by 4 plus 235.2 multiplied by, from here to here is 3 because it's acting at the center. 3 plus 4 will be 7 plus another clockwise 100 multiplied by, this is 6 plus 4 is 10 plus 75 multiplied by 4, 10, 14. And lastly, we have our 20 acting at the center there. 20 multiplied by, from here to here will be 1, plus 4 is 5, plus 6 is 11, plus 4 will give us 15. Therefore, we shall have 120 plus 16h will be equals to 80 multiplied by 4 plus 235.2 by 7 plus 100 by 10 plus 75 by 14 plus 20 by 15 shall give us 4316.4. All right, 4316.4 minus 120 will be equals to 16h, and h will be equals to 4316.4 minus 120 will give us 4196.4 all divided by 16, and our h will be 262.275 Newton. So I always advise that we put the value here, 262.275 Newton. All right. So we have done our moment for B. So let's go ahead and do moment for H now. Moment for H. We still say the sum of anti-clockwise moment equals the sum of clockwise moment. So we will rub all this off. Okay, and then we say this is where we are concentrating on. The 20 part will be anti, the 75 will be anti, the 100 will be anti, the 235 will be anti, 80 will be anti, 60 will be anti. It's only B that is going to be clockwise. So we start. For anti-clockwise, 20 multiplied by, the distance from here to this point will be 1, plus 75 by 2, plus 100 by 6, plus 235.2 multiplied by, from here to here is 3, plus 4 is 7, to there is 9, plus 80 multiplied by 6, 10, 12, plus 60 multiplied by 2, 4, 6, 12, 12 plus 4, 16, and this will be 18, will be equals to B, multiplied by 16. So if we add all that together, we shall have 4926.8 will be equals to 16b. So 4926.8 all divided by 16 will give us b, and b will be equals to 307.925 Newton. So I also suggest that we write the value of b here, or value for b, 307.925 Newton. Okay, and then we clean all this. So now let's check the second. We've done the first question. The second question, prove your answer. To prove, we say the sum of upward forces equals the sum of downward forces. For our upward forces, we have 262.275 plus 307.925 will be equals to downward forces. We have 60 plus 80 plus 235.2 plus 100 plus 75, and of course plus 20. So if we check how much do we have here, we shall have 570.2 Newton will be equals to 570.2 Newton. So that is our proof for 1 mark. And then we can go to question number 3 now. They say we should calculate the bending moment about point B, C, D, E, F, and E, F, and G. Okay, so we will start the bending moments. We shall start with bending moment of A. We have 60 going down minus 60, and the point here is 0. So we shall have 0 Newton meter. Bending moment about B. This is B. So we say minus 60 multiplied by 2 shall give us minus 120 Newton meter. BMC. BMC, we say minus 60 multiplied by, from here to here, we shall have 6 plus B is 307.925. It is positive. Multiplied by, from B to C, we have 4. So, for all this, BMC, we shall have 871.7 Newton meter. For BMD, at this point, you can either start from left or from right, whichever one is easier for you. But not to waste too much time on a question like this, look for the simplest form that can make you understand. So I'm going to try from the left hand side and also from the right hand side so that you can see if we are correct or not. So also I encourage you to try something like that so that you can see if you are correct or not before you move to the next question. So BMD, we say minus 60 multiplied by, this is D point. This will be 3, and this is 6. That is 9. Plus, we have B there, 307.925 multiplied by, from here to here is 4, to here is 7, plus, we have 80, we're going to say minus 80 multiplied by, to D is 3. Okay. But we are not done. We have a UD here. So we're going to say plus minus 235.2. No, sorry. We're going to use, this one is out now. This is out now. So we will say 4 multiplied by 9.8 shall give us 39.2. So we will say minus 39.2 multiplied by, the distance there is 3, multiplied by 1.5. So for BMD, we shall have minus 388.525 Newton meter. So that is from the left. If we have to calculate from the right, which is much simpler, we will say from H to D here. So we will say this is H, which is plus. So we will say 262.275 multiplied by, to D, we have 2 plus 4, 6, plus 3, which is 9, plus the G here to D. We have 10. So we will say minus 10 multiplied by 2 multiplied by 1 plus, from here to here will be 7. 4 plus 3. Okay. Plus minus 75 by 4 plus 3 is 7, plus we have a UD here. We say minus 39.2 by 3 by 1.5. Okay, it's going to give us the same value, which will be minus 388.525 Newton meter. All right, then we have BME. So we can take it from the right, which is much simpler. We'll say 262.275 multiplied by, this is 2 plus 4 is 6, plus minus 10 by 2 by 1 plus, to BME is 4, plus we have minus 75 by 4. And that will be all. So our BME will give us 1173.65 Newton meter. And then our BMF shall give us, this is BMF, we have 262.275 multiplied by 2 plus minus 10 by 2 by 1. And that will give us 504.55 Newton meter. All right. So we are left with BMG. To do our BMG this side, we will say 262.275 multiplied by 1 plus, we have 10. To this side is going to be 1. So we will say minus 10 by 1 by 0.5. Our BMG will give us 257.275. 257.275 Newton meter. Okay, so we have calculated for all the bending moments. And then the last one, they said we should draw the shear force and the bending moment graph, and of course show we must show the highest value. So my advice to you, whenever you see a question like this, redraw the bending, the beam in a separate side and do all your calculations on a separate side so that it will be easier for you to draw your shear force and the bending moment graph. So look at every point. You can just make a dotted lines to be easier for you to sketch. About every point. So we have 0 here, we have 0 here. So we have 60 pushing down, minus 60 Newton. So minus 60 plus 307.925 will give us 247.925. So we push up 247.925 Newton. Okay. All right. This will be negative. And then we move again. 247.925 minus 80 will give us 167.925 Newton. Okay, and then we have our UDL. There we will slant down. So 167.925 minus, we will say 4 multiplied by 9.8 multiplied by the amount of distance we have there. All right, and then our value will come down to 50.325 Newton. Okay, and then the remainder of this, the UDL, shall also give us minus 67.275 Newton. And then we push to the right again. We have 75. So minus 67.275 minus 75 will give us minus 242.275 Newton. Okay. And then we have a UDL of 10 Newton for 2 meters, which is 20. So it's going to be minus 242.275 minus 20 will give us minus 262.275 Newton. And then minus 262.275 plus 262.275 will give us 0. So we have a negative here, and this will be positive. So therefore, they ask us to show the highest point. So our highest point here will be about the value of negative 262.275 Newton. Okay, we don't consider the negative part, we just choose the highest number. And if they ask us what is the minimum point, we shall say 50.325 is our minimum point. So that is for the shear force diagram. So now let's do the bending moment diagram. Here, for the bending moments diagram, we don't need to add and subtract. For that, you just take the values of what you have calculated so far and plot it in, and that is it. Our first point, second point, third point, the fourth, the fifth, the sixth, the seventh, and of course the eighth. Okay, now BMA we know it's 0. That's our 0. BMB we say is minus 120 Newton meter. Here on bending moment we don't draw straight. We must be slant all through. So to point B, we shall have minus 120 Newton meter. Please make sure that you always write the value about every point, because that's where they will score you marks. Okay, BMC is 871.7. That is positive. So we have to go up. This is C. All right. So we say (871.7 Newton meter). All right. BMD is minus 3.88. So we have to push down. And here we have bending moments. Because we have bending moment, it must actually curve here. It's not going to be direct slant. So therefore, to this point, we can just go this way. All right. And then we shall have our minus 388.525 Newton meter. Okay. BME is positive for 1173.65 Newton meter. So also we have to bend there. Okay, we have to bend there, and that is that. All right, and then for BMF, it's also still positive. So here we can slant down. That's 504.55 Newton meter. BMG is 257. So we still slant down and we write 257.275 Newton meter. And then BMH is 0. Although here we must bend. All right, bend. Okay, so that is that. Also here, our highest point will be 1173.65 Newton meters, and our lowest point will be 120. So that is that about your bending, your beams, about bending moment, which you can score for about 20 marks in this